Hi, everybody. I see we have a few people who have entered the room. We're going to give the rest of us a minute or two just to get on the line. So we'll be kicking things off in just about a minute or two. All right, it looks like we got a good group in the room and more will join. Welcome to today's session, everyone. If you haven't joined these before, our Torque Talk sessions are it's a monthly webinar we hold to give the Quali community a chance to see what's new with our platform. And we found that it helps if we dive deep into one specific topic, right? So we'll be able to see some of the latest functionality in our platform, but this month our speaker is going to be focusing specifically on reusability and composability for Terraform. One thing I always want to make clear to everyone on the line is this is an interactive, informal session. So we have the Q&A function here. Please feel free to submit questions at any time. If we have a chance, you may hear me come off mute and pose questions to our speaker, if it comes up at the right time. So don't be surprised if you hear that. If you haven't already, if you don't have an account of Torque, we do offer a 30-day free trial of our enterprise platform and a permanent free tier of our more limited functionality. One of my colleagues is going to be dropping a URL to go create a trial account. It helps a lot to follow along in these sessions and get a real close idea of what you can do with the platform. I'd like to introduce our speaker for this month's session. So today's speaker is Lior Vardi. He's one of our system architects. Lior spends almost all the time working with our customers and whatever extra time he has working with our product team. So if you have a question about Torque, Lior should be able to answer it for you. That should be about enough for me. Lior here is going to kick it off with just one or two quick slides. Going to give you an introduction to the topic, and he's going to dive in. We should have about a 30-minute session in total, and then after that, we'll dive into any of the questions that we didn't get to live on the call. Lior, take it away.
Hi, so hello everybody, Lior here, and let's start by reviewing our agenda for today's talk. So today's topic is a bit about how you can import your infrastructure as code assets and specifically Terraform into Torque and turn them into reusable deployments that can be deployed over and over, and then even break them down into building blocks where each one of those building blocks can be used independently or recomposed as part of that same original deployment. So we're going to be importing an infrastructure as code Terraform module that was built locally and used to deploy using Terraform normally. We're going to import that into our Torque account that only has the agent set up. And then we're going to turn that into a multi-building block deployment by breaking it down and making each one of the components inside reusable. And then we're going to design the same original environment using those new blocks. And we'll play around with some parameterization settings and a catalog design. And after that, we'll automatically have infrastructure as code single blueprint template file that allows us to redeploy our environment again and again as we want. So before I dive into that and show you what the environment looks like, I just want to show a quick diagram of what the sample environment is that we're going to be deploying. This is a very standard front-end, back-end web application. I chose WordPress as a stand-in. So we have a WordPress front-end and a MySQL back-end, and it's going to be deployed into a multi-subnet VPC, which is a virtual private cloud on AWS Cloud. with an application load balancer that's balancing the traffic into the front-end instances. So that's the basic idea, and that's the environment we're going to be deploying and creating. So this is my Torque new space that I created specifically for this webinar. It's empty. It has no blueprints in it, and it doesn't have a repository connected. I'm going to use a repository that I created ahead of time that has a single Terraform asset in it called WordPress single module. And this Terraform asset has the whole environment that I just showed. So essentially it has a VPC creation, and then some subnets, networking subnets, an internet connection, a routing table, and association of those subnets to the routing table, and then two compute instances, or rather one compute instance for MySQL, and then multiple compute instances according to a variable for the WordPress frontend, and then the load balancing aspects, the target group, and everything that's needed to create the application load balancer. So in order to bring this environment into Torque, I'm going to go to the main page of the repository and copy that URL. And then in Torque, click the Add a Repository button, choose the GitHub option, and give my repository a name. Let's call it my repository. And because I'm already connected to GitHub, it'll use my access token in order to give Torque permissions on this repository, after which I can choose to discover assets. Discovering assets is Torque's way to use the read permissions that it has into the repository to show you what IIC modules it detected inside your repository. This repository only has a single Terraform module, so it's very easy. We can choose that one and generate a simple blueprint out of it. So now we have one blueprint in our list. A blueprint in Torque is essentially a template IIC YAML-based file that points to our infrastructure assets inside. So you'll see inside it has a single grain that's Terraform type. And after importing it without making any additional changes, we can already launch it. It'll automatically have permissions to our AWS account based on the execution agent that's connected and the secure authentication settings that are on that. So I don't even need to provide any of that. I can give my environment that I'm launching from this template a name. I can give it a duration. Let's give it a duration of 1 hour. And then you'll see that also I have parameterization built in based on the variables that my Terraform module had. So for example, I can control the instance count for the WordPress frontend. Let's change it to 1 instance, and let's use a larger type, instance type. And then we can launch this, and it'll start our deployment. Now, typically this particular Terraform module deploys in about 3.5 to 5 minutes. And you can see an estimate at the bottom here for how long the launch is going to take. In order for us to not need to wait that time, I pre-launched an environment from that same template. So this is that environment, and you can see that the launch completed in about 4 minutes. After the environment is launched, already just from importing the template to Torque, from importing the Terraform deployment to Torque, it became a template, meaning that it can be deployed multiple times. And assuming there is no hard-coded naming that doesn't have any random element in it inside the deployment, those environments will be completely separate, and Torque will manage the state files automatically for you. So that's one benefit that we got immediately from just importing our Terraform asset to Torque. The other benefit is that as part of the Torque's resource introspection feature, we can see essentially the content of the state file. So each resource that we deployed inside our Terraform will show in this resource list. We see that this Terraform had 22 resources, and we can click into any of them. For example, we can click into one of the instances, the MySQL instance, and see additional information on it. So we can see what AMI it came from, what its Amazon resource name is, and what its IP. And we can filter those. For example, if we just wanted IP, we can search for IP and we'll see the public IP here. Additionally, for a higher level end users that are not cloud experts or not Terraform experts, we also have the simple view. And the simple view allows you to predefine which types of resources you want to highlight for your end users. in a sort of templating setting that you do in YAML format. And right now it's only showing us the compute instances. So you'll see in the simple view, we have for each one of our compute instances that are in the Terraform deployment, we have the name of the instance, the public IP, private IP, instance type, availability zone, and the AMI image. And we can copy any one of those outside. And we can even run some day two operations using our secure authentication to AWS to do stuff like stop the instance or restart it. So all of this is stuff that I got out of the box immediately from just importing my deployment and running it through Torque, rather than running it directly through Terraform. However, in order to get the full, let's say the full scope of capabilities that Torque offers, then we can go one step further and we can take this template and break it down into building blocks. So what does that mean? Well, our template right now has an environment, a network environment for our application to run in, and it has a backend application, which is the MySQL database, and it has a front-end application, which is the WordPress website. Let's turn each one of those three into its own component that can be controlled separately and can be composed separately, which means that, for example, we can then reuse it and have an environment that only has the network environment in the MySQL. Or we can have a blueprint that presets the amount of instances that we want for the WordPress to 4, and then we can call that a robust deployment and have a different blueprint where it's only one instance and call that a minimal deployment. All of that becomes possible, as well as other capabilities like updating each one of the components separately by breaking down our Terraform deployment into multiple building blocks. In order to do that, I'm going to switch to my IDE, which is VS Code. And in here, I already have cloned the repository that we're working in locally. And I'm going to start by just taking my deployment folder and duplicating it 3 times. And then we're going to name each one of those based on the components that it's going to be. So this one will be the environment infrastructure. And this one will be the MySQL, for example. And this one will be the WordPress. And now if my Terraform is well structured, and I know that it is, all I need to do is for each one of these, take out all of the components that are not part of that specific part of the deployment. So for example, the MySQL and WordPress installation scripts are not relevant to the environment infrastructure. And if I look at the variables, there are some variables here for configuring the database that I can remove. And there's some variables that are related to configuring the WordPress instances, and I can remove those as well. I'll be left with just the AWS region. And then in the main file itself, I'm going to remove everything that's not related to the networking environment. So these local parameters are related to the WordPress, the VPC, and the subnets, and the internet gateway is all part of the networking environment. But then from this point here, the 2 compute instances are not relevant. The MySQL security group is not relevant. The WordPress security group is not relevant. There is a default security group that I'm going to keep. And then everything else is related to the load balancing, so I'm going to remove that as well. And I'm going to adjust the outputs as well. All of the outputs that are not related to the networking environment, I'm going to delete those. And now, technically, I'm already done with one building block. I have a Terraform deployment that only does the environment infrastructure. But of course, we'll need to add outputs here to connect it to the next building block. So let's do that first. So we're going to do the MySQL building block. We'll remove the WordPress installation script. We'll go through the variables and delete any that are not relevant to the MySQL, which is just WordPress instance count. And then we're going to go through the main and do the same thing we did with the environment infrastructure. We'll remove anything that's not related to this particular building block. So we need these variables. We don't need the VPC. We don't need the subnet. We don't need the internet gateway, the route tables all the way over here. And of course, we don't need the WordPress application and everything else that's related to it. So we're left with just the MySQL instance and the MySQL security group. Now we'll notice that there is some references in those to stuff that was provisioned in the environment infrastructure. So obviously those need to become variables. So let's do that now. For example, here in line 34, the subnet ID instead of coming from previously created resource in the same asset, it's now going to come from a variable. And the same goes for the default security group ID. We're going to change that into a variable. And for the VPC ID. And now, of course, it gives me red squigglies because we need to create these variables. So let's go ahead and do that. We'll go to the variables.df and we'll create 3 new variables. One for each one of the new variables that we added here. So one for the security group. And one for the VPC ID. And one for the subnet ID. Now those values are going to have to come from somewhere, which means that we need to add them to the outputs for the environment infrastructure building block. So let's do that now. This will come from the AWS VPC, sandbox VPC.id. And this one will come from the AWS subnet, app subnet a.id. And let's also adjust the outputs of the MySQL. Right now, we don't know what outputs we're going to need for the WordPress, so we'll just remove all of the outputs that are not relevant. Remove these two and keep just the MySQL IP. Okay, now let's go for our last building block, the WordPress. We'll remove the MySQL installation script. Under the variables, there's nothing here that we need to remove. And let's go to the main. Similarly to what we did with the MySQL, we're going to remove all of the networking elements. And the MySQL application, of course. And everything else is stuff that belongs here. Now, exactly the same as we did with MySQL, we're going to need to turn anything that's connected to the previous 2 components, we're going to turn that into a variable. And over here, I know that there's going to be multiple references. So I'll select all of them with Control F2 so that I'm changing them all at once. So this is our subnet A. And over here, we have a reference to the MySQL private DNS, which we haven't defined yet as an output. So we're going to add that as an output in a moment. And then here we need the VPC ID. And this default security group doesn't belong here. It's created in the environment infrastructure. This one didn't catch for whatever reason. Let's fix that. Okay, and here we need the subnet B. And now we need to add these missing variables to our variables list. So let's do that. I think we can copy over from the MySQL the 3 that are the same. And then we'll just add subnet B. And let's verify that we covered all of them. Oh, we still need the MySQL private instance DNS. So let's add that one. And now there's two here that aren't yet defined as outputs in the previous components. So let's add subnet B to the environment infrastructure, to the outputs, of course. And under the MySQL, we'll add another output for our private instance DNS. Now all we have left to do is adjust our outputs, which means just removing the MySQL IP. And we're done with creating our building blocks. So we'll go ahead and check them into our source control repository. And we'll commit that and sync that back into the remote repository. And now we'll be able to go use them in Torque. So I'm going to switch back to my web browser. Okay, and now I'll go back to the repository screen and I'll discover inside the repository, and we'll see that it detected my three building blocks: environment infrastructure, MySQL, and WordPress. We can generate blueprints for them, but we're not going to use those blueprints as is like we did with the single module. Instead, what we're going to do is we're going to publish them as assets. When you publish a blueprint as an asset, that means that in our visual designer for new blueprints, we can reuse that asset as a building block for composing different types of blueprints. So let's do that now. Let's click the new blueprint button, and we'll create a new blueprint called WordPress Modular. And instead of creating that blueprint by discovering an asset, we'll use the asset library that we just generated by publishing those three assets. So we'll just click the add button here to add the environment infrastructure, and click again to add the MySQL, click again to add the WordPress. Now we need to set their dependencies to essentially tell the system in what order to deploy them. So we'll do that by stretching this line here, and then stretching this line here. And we'll also add the dependency on the environment infrastructure for the WordPress so that it can relate to its inputs. And now the only thing that's left for us to have this full environment is to set the inputs. So let's do that for each one. For the environment infrastructure, we just need to select the agent. For the MySQL, we need to select the default security group ID. What you'll notice is when I click this, it will automatically suggest outputs from the previous component in the blueprint, the previous grain. We call those grains because they are part of the sandbox environment. So this MySQL can relate to the default security group ID that I defined as an output from the environment infrastructure. And that makes it so that it automatically uses that output. And then we'll do the same for the application subnet A ID and for the VPC ID. And we'll confirm the agent selection. And we're done with the MySQL configuration. And now let's do the WordPress. Again, we have suggestions from both the MySQL and from the environment infrastructure. We'll fill in the default security group ID, the subnet ID for subnet A, subnet ID for subnet B, the private DNS from the MySQL instance, and the VPC ID, and select the agent. And now hit the save button. And we've got a launchable blueprint that is identical to our original deployment, except that now the deployment is broken up into building blocks, and we can decide which parts of those building blocks we want to publish as inputs to the end user. So for example, I want to publish the region to the end user as an input, and Torque automatically detected that this input AWS region also exists on the other two grains. So I'm going to publish it on all three at the same time. And also I want to publish the instance type, again, on both grains, and the number of instances for the MySQL, for the WordPress, sorry. Once I did all of that and I hit save, you'll see in our parameters page that we now have 3 input parameters for this blueprint. We also want to add an output parameter. Let's add an output parameter for the WordPress link. And here in the value, it'll automatically suggest to me all of the different outputs that I have on my different components in the blueprint. I want to add the WordPress address. And we'll mark it as a quick link so that it appears as a clickable link in the outputs. And again, we'll save our changes. And now we can go ahead and launch our environment. Let's give it a duration of 1 hour, which by the way means that after 1 hour, it'll automatically destroy the environment. And you can see in the parameter screen that we already reduced the list of parameters to just the ones that we want the user to be able to touch. So let's make this 3 large instance types and a count of 3, and give it an activity type of production. This is, by the way, part of our auto tagging capability, which allows you to set both built-in and custom tags that will automatically apply to all of the resources within each one of your Terraform deployments. That means that even if you didn't specify any tags, Torque will automatically tag all of your resources so that you can later use it in the cost explorer or in budgeting or monitoring or permission settings or any other application that relies on tags in order to be able to differentiate the different deployments and trace them back to a specific owner or a specific environment. We'll go ahead and launch our environment, and you'll see that our grains view is already significantly different from what it was in the previous deployment. And now we're essentially able to follow the deployment of each component separately. And if we had components that are capable of deploying in parallel because of their dependencies, then we would see those in the different columns here. For example, a common structure that we see is to have one infrastructure grain, and then many backend and front-end servers, and then let's say a load balancer or a configuration script that runs after all of them. So you'll see each one of the columns grow in size depending on how many components are running in parallel. But in this example, we only have one component at a time. While we are doing the deployment, we can also look at the log section to see exactly what Torque is doing at any given point in time. So each deployment of a Terraform asset consists of a preparation phase in which it spins up a container and installs the relevant Terraform version. And then an initialization phase in which it queries the repository and brings us our assets, which actually looks like it failed this time, but we can retry the deployment. This is, by the way, part of the update feature that we can automatically retry a deployment once it fails for a reason, like in this case of just not being able to contact the repository. Let's see what's going on here. Our modules are checked in and pushed to source. Okay, it looks like we might be running into a minor technical difficulty. Yeah, let's see if there is some sort of issue with GitHub. Okay, well, reconnect our repository and give this one more try. If nothing failed, it's not a good demo. That's my motto for this sort of thing. Okay, it looks like there might be some sort of issue related to Torque's connection to GitHub. So that means that unfortunately we won't be able to see our deployment finishing. But what I can do is move to a different Torque space. Oh, let's see. No, it's failed again. Okay. So let's instead move to a different Torque space where we have a similar environment, and I'll show the successful deployment from that. So this is a similarly structured environment. It has one additional grain of a Bastion deployment, and you can see what the resource table would look like. The main difference from what I showed in the previous environment that was deployed successfully is that we can now sort by a particular grain and see all of the resources of a particular grain. And additionally, we can choose when we're updating, we can choose to update the deployment of a particular grain. For example, scale up the instance type of the WordPress or the amount of instances that the WordPress frontend has without changing or harming the other grains in the environment and without having to redeploy the whole Terraform of the entire environment. We're just doing it on a single grain basis. And similarly, Torque has a drift detection feature that compares the current state in the cloud to what the Terraform state file was after the deployment. And we can use that to detect changes in the environment configuration and essentially detect drift in that configuration. And that is also done on a per grain basis, which means that if the WordPress server went down for whatever reason, we would see an error only on the WordPress grain and not on all of the grains in the environment. So this is also another reason why to use building blocks instead of having all-in-one deployments. And of course, having those as building blocks means that we can potentially have different configurations. So if we wanted to make an environment, let's call it MySQL, which only had the environment infrastructure and the MySQL, we can do that with those building blocks that we broke up from our initial deployment without having to make any additional changes in our actual Terraform code. So this is another favorable aspect of using building blocks. And just that quickly, I have another blueprint in my catalog, which I can then choose to publish later. So I think in the interest of the time that was allotted to the session, let's stop the demo here and go to questions.
Yes, thank you, Lior. It's not the first time we've seen a unexpected failure in a demo, so I wouldn't worry about that.
I'm sorry
We did
about
have a
that.
no problem at all. We did have a question come up when you were navigating. I saw you navigated into a different space and then opened up a new environment. Around them, we had a question asking to go back to that view of environments. Do you mind just taking a walk through the environment view and what we're showing here?
Yes, definitely. So the environment view is the way that Torque allows you to essentially monitor all of your active or historical deployments of a particular Torque space. A space is a logical separation inside Torque, where each space can have its own catalog for self-service consumption by the end users and its own blueprints and asset library lists. And you can be connected to a different repository or a different branch. And then, of course, any environment that's launched within a space will appear in the space's environment list, and you'll be able to see its current status, when it was last accessed, what its duration is, and when it's expected to end, and who the owner is of that particular environment. And as a Torque global administrator, which I am specifically, you can go into a currently active environments and see the actual current status of them and look at those logs and etc. Normally, only a user who is permitted or an owner of an environment can access an environment. Does that answer that question?
Yes, I think that was perfect. It was a general question, but I thought it was uh, something that we glossed over and thought we should go a little more in depth on. We did get another question asking which version of Terraform we support.
So Terraform, Torque supports Terraform out of the box up until version 1.5.5, which is when HashiCorp changed their licensing model to not allow you to compose with Terraform automatically. However, Torque also supports the new open source fork of Terraform called OpenTofu on any version, including its latest. And if you want to use Terraform with versions that are newer than 1.5.5, you can do it, but you'll have to host the Terraform binary on your own server and point to that. And we have a special syntax for that in our Blueprint IAC YAML. Which, by the way, we didn't show that for the blueprint that we generated. So let's go back to that real quick. The environment that we composed of the multiple modules. I promise that it auto-generates in infrastructure as code YAML for us as well. So we can see that it actually did that. This Torque blueprint was automatically generated for us by using the visual designer.
Thank you for that, Lior. We just have one more question here, unless anybody wants to submit others before we wrap up. But we had a question asking about integrations with Jenkins.
So Torque can integrate with Jenkins as well as other CI/CD pipelines and other community tools. In our community tab, you'll see all of the integrations. And the way that this integration works is essentially you're offloading the responsibility for deploying infrastructure cloud environments from Jenkins to Torque. So if your usual Jenkins pipeline would consist of stuff like compiling code and then let's say publishing artifacts for that code, and then using those in a set of tests, and those tests would include deploying infrastructure. Instead of having the test deploy the infrastructure, you can have Jenkins contact Torque through the integration to deploy a specific blueprint from your catalog. And it can be the same blueprints that your users are using from the self-service catalog. And then once that blueprint is up, you can use, again, the same integration for the API to get all of the environment details and give that to the test. The test can use that environment outputs in order to know where the test assets are in order to test them. And then at the end of that, there will be another pipeline step to end the environment automatically. So essentially, it allows you to encapsulate the responsibility for handling infrastructure environments to Torque, while allowing Jenkins to do the job of defining the pipeline and running the different pipeline steps.
That's perfect. And that's it. That's all we have for questions. Want to thank everybody for taking the time to join us this week. I want to thank Lior Vardy for taking the time to present here as well. I thought this was really helpful. Another thank you to Corey on the back end, making sure everything here worked correctly. Please make sure you head over to quali.com. We have plenty more resources here, especially specifically related to Terraform, and create a trial account to get started using it today. Thanks, everybody.